Hi friends, welcome to my channel TechnoBuzz. This is the second part of the series, how to set up an overset mesh in OpenFoam. If you are visiting my channel first time, please do like, share and subscribe. And do not forget to click the bell icon. Now, let us start the video. In part 2, we will see how to set object rotation with overset mesh technique. In part 1, I have presented brief introduction, geometry creation and folder structure needed for creating overset meshing. Further, I have explained the procedure for linear oscillation of the object. Now in part 2, in this part, I will present procedure for object rotation with two methods. First, using inbuilt module and second, using data file input. It may be noted that Overset Meshing module is not available in foundation version of OpenFoam. In this video, I am using OpenFoam2406 version of ESI. Now let us have a recap of the simulation domain considered to demonstrate the overset meshing. A rectangular capsule with two circular inlets on either side is considered with an opening on one of the sides. A closed manifold object is placed centrally within the capsule. As said, the overset mesh is created by merging the outer and inner grids, which are generated separately with individual refinements. So this is the cross section of outer mesh, which can be named as background grid. This is the inner grid, which is termed as on-body grid. Now, after merging, the final overlap mesh can be seen like this. It can be observed that both the grids have their own refinements. In part 1, I have clearly explained the folder structure, details of important files. So now we will continue with the same format with only a change in file dynamic mesh dict. This is a minor change. Now this file dynamic mesh dict is present at the path background constant. As I said, folder background is the main working horse and all modifications related to dynamics of moving objects can be done here only. In method 1, we will try the inbuilt option. The syntax is given here. The solver is multi-solid body motion solver. The parameters of moving zone are given under the block multi-solid body solver coefficients. These are the parameters. The motion specified to the object is axis rotation motion. The geometric center of the object is given as origin. The object is rotated over this point with a radial velocity of 30 degrees per second in z direction. Now, let us make this modification in the file dynamic mesh dict and launch the simulation. Now let us go to the working directory and make the required changes. So go to background and constant and open this file dynamic mesh dict. So here we see in the earlier simulation, in the part 1, I have given oscillating linear motion. So there are different motions that can be given here. These are listed here. Now we will try the option axis rotation. So I just copy paste this. So now here we can see within the moving zone, the solid body motion function is axis rotation motion. The origin is given here. This is the geometric center of the rotating object, and the radial velocity is 30 degrees per second in z direction. So now this is done. We save the file. No other change is needed here. You can see here the STL files are present. Now there is no need to change within this folder, because the only change we are doing is the rotation option. So this is the main working folder, and there is no need to change in this folder. Now we have again this file. Once we launch this file, meshing will be done. So now let us open the terminal and set the path to the working directory. The first one is we have to change the solver option. Okay, now we have set the OpenFoam2406 as the default solver. Now we will launch the bash file. All done. So this is done. Now let us explore the folders and see if the boundaries are selected correctly or not. Go to on body, constant, polymesh. Here we see the boundaries selected correctly. Now we go to background, constant and polymesh. Here we see open, 5 boundaries are there: open, inlet 1, inlet 2, domain and object. So all the boundaries are selected correctly. Now we can launch the case. So go back to the terminal and set the path to the background, because we are going to run the simulation within that folder. So now we can launch the case using the command overpinpul dym foam and launch. I'll be running the simulation for 5 seconds. So once the simulations are done, I will show the animation. The simulations are completed. I created the animations in ParaView. This is the cross-sectional view where mesh refinements of background grid and dynamic grids are seen. The surface mode view is presented here. Now let us explore the second method, data file input for rotation. So the second method is data file input. In this method, the only change needed is here. So here we are using tabulated 6 degrees of freedom motion, and this is the center of gravity, that is the geometric center of the rotating object, and then this is the time data file name. So this is the path of the data file. So with this modification, let us launch the case. Now let us open the working directory. Here go to background and constant. Now here open this file, dynamic mesh kit. Here we have axis, rotation, motion. Now we will change this part as discussed. We'll modify these two. tabulated 6 degrees of freedom motion. Now we need center of gravity. And we have to take this origin only. Okay. So we delete this. Now I have to give the path of the file. So this is the path. This path points out to the same folder. So what we need to do is close this file. Now we need the data file here only. So we go to the on body constant. Here we do have this file. Let us copy this file and paste here. Rename this as object. So this is the file name which we have here. This one. So once this is done, we have to modify this data so that we have a circular motion. So let us copy the data here. So I have explained this earlier in earlier videos. I will do the same here. The first column corresponds to time. The second block corresponds to translation. Here we have X, Y and Z directions. And the third block corresponds to rotation in X, Y and Z directions. Using this setup, we can give multiple degrees of freedom to the object rotation. So here I kept the translation same, no movement in the body. The body is stationary at one location, but it will rotate. So I have given the rotation angle in the Z direction. So it will rotate by 30 degrees in 1 second. So accordingly, I have given the data here. So now let us close this file. So this is what we need to do. Then now we can open the terminal, set the path to the working directory, background, then set the default solver to OpenFoam2406. So as meshing is already done in the earlier cases, we'll continue with the simulation command. So the simulation is started. The case will run up to 12 seconds. After completion, I will create the animations in ParaView and show. So the simulation progressed well. I stopped the simulation at 10 seconds. I created the animation. So this is the animation of the simulation with data file input for object rotation. The cross-sectional view and the surface mode view are presented here. So finally, in this video, I explained the procedure for object rotation with Overset Meshing. In the next part of the video, I will present the procedure for object translation with multi-degree oscillation and rotation. Stay tuned and thanks for watching. Please do like, share and subscribe.